A lot of students in this course really do need a review of factoring, and because factoring plays a big role in this chapter. Now, this chapter is focused on rational expressions and rational equations, and the word rational comes from the root word of ratio, and I have a kind of nice little story about that at the beginning of in my book in this chapter about Pythagoras and his followers and what rational meant to them. And so I encourage you to read that. Anyway, there's two reasons we factor things in algebra, two big reasons. One is to solve equations, and we'll use that technique in a later chapter. And but to solve polynomial equations, we usually use a factoring method. And the other primary reason is to reduce or simplify fractions in order to work with them in this chapter. So has an important role, and let's get started. In this section, I'm going to, or this topic, I'm just going to review the factoring the greatest common factor out of a polynomial. So here's a real simple one. Let's factor the following. 12x minus 8. All right. I should tell you that in algebra, a term is a piece of an equation or an expression that is separated from everything else by either a plus or minus sign. So here we have two terms, a 12x and an 8, and it's separated by a minus sign. So two terms, and because it's a polynomial, we could also call it a binomial, two-term polynomial. Anyway, factoring is a division process. And when you look at 12 and 8, you think, well, is there a number in common with both of those? And by in common, I mean, is there a number that would divide into each of them? And there's 2. We could divide each of them by 2. And so 2 is a factor of this expression. But there's a larger factor, and it's 4. We could also factor a 4 out, or we could divide each part by 4. So always choose the largest, the greatest, and in fact we call it the greatest common factor. So the greatest common factor here between 12x and minus 8 is 4. So I'm going to write a 4 here, draw parentheses, and what I put inside comes from division. And so 12x divided by 4 is 3x, and 8 divided by 4 is 2, but there's also the minus sign. So I have 4 parentheses 3x minus 2. Now I hope you notice that it's very easy to check this, and we do that by multiplying it back. And so 4 times 3x is 12x, 4 times minus 2 is minus 8. In other words, if we distribute back inside, use the distributive law, we're basically taking the parentheses out and going back to the beginning. So there's an important observation for you. Your factoring is correct when what you end up with, if you multiplied it all back, you would get the beginning. All right, now that's not quite accurate because it's possible you can do some factoring, but you're not done factoring, all right? So you do have to factor as far and completely as you can. Now here, 3x and 2 do not have a common factor other than 1. I mean, you could divide both by 1, but that wouldn't do anything for us. And so, in fact, we say 3 and 2 are relatively prime. That means they share no other factors other than 1. So we cannot factor this, which means that we're done. 4 is the greatest common factor, sometimes called the abbreviated the GCF for greatest common factor. All right, and that's your goal here. So let me, as you might expect, it's going to get a little more complicated. So I'm going to work a couple more examples here. So I'll raise the board and put up another one. Here's our next one. It's factor 9x to the 4th minus 6x to the 3rd power plus 3x squared. And you probably noticed immediately that 3 is a common factor of each of these 3 terms. Now there's 3 terms. That makes it a trinomial, a 3-part or three-term polynomial. And 3 is the common factor of the coefficients. A coefficient, by the way, is the constant number, or the number multiplying the variable part. Anyway, so we can factor a 3 out because all of these are divisible by 3. But 3 is not the greatest common factor. If you look again, you'll see, well, there are x's here. And so could I factor x out? Yes. And some students stop there. They factor x out. And they don't get full credit because it's not totally factored. You can actually factor out x squared. So how does that work? When I have an x in common with each term, then I can always factor out the smallest power. And the smallest power is 2. So I can really factor out x to the second power. Well, let's see what's left over. So if I took 3x squared out of 9x to the fourth, or pull it out, what I really am doing is dividing it, this term, by my factor. And 9 divided by 3 is 3, and then x to the fourth divided by x squared is x squared. So that's 3x squared. What's my middle term? Well, if I pull a 3 out of here, I get minus 2, and then I'm going to get x, because x cubed divided by x squared is x to the first power. And finally, my last term is what? Well, it is 3x squared, which happens to be my factor. Now, one mistake people will make is just, okay, well, it comes out. So they'll just close the parentheses here and be done with it. But there are 3 terms, and when we factor out a common factor, there must be 3 terms remaining. And in fact, if you divide 3x squared by 3x squared, you don't get 0, you get 1. So it's a plus 1. All right, so now let's check this, and this one I'm going to write down here, write out the check, because I want to draw a few things. So 3x squared, parentheses, 3x squared minus 2x plus 1. And by the way, I'm finished factoring here because there are no more common factors among the coefficients other than 1. In other words, I can't divide everything by 3 or by 2. And not every term has an x in it. And so without a common x, I can't factor out x, can I? So this is totally factored, and this is my greatest common factor. So in checking it, I'm going to just multiply it back. I'm just going to redistribute. And so 3x squared times 3x squared is going to be 9x to the fourth. And then we have negative 6x cubed, and then plus 3x squared. And it exactly matched up here. Now, I have actually seen students factor something, check it, and this is different for what they started with, but then they just leave it. So, don't check without making sure it's what you started with. I don't know why people do that, but it happens. And all right, I wanted to show this because I mentally check all my factoring. Okay, now I'm pretty good at that because I've factored thousands and thousands of polynomials. So I multiply this stuff back in my head. It's you may not be at that point yet where you can reliably do that, but at least if you need to write out these steps, by all means do so. But even as much algebra as I've done in my lifetime, I still check my factoring. And if you don't check your factoring, then you're probably going to make mistakes. And so one thing I do find is that people who check their factoring on every problem in this chapter usually get an A on that test. So it shouldn't be a surprise because they're doing what they're supposed to be doing as far as quality work. All right, well, I'll put another one up here.